Now students, let's solve this question. This is a cantilever beam. Sometimes statement is also given in question. A cantilever beam AD of length 6 meter carry 3-point load from fixed end. 4 kilonewton from 2 meter, 3 kilonewton from end fixed end, then 3 kilonewton at free end. So this is the diagram of a cantilever having 3-point load. Now we'll draw the shear force and bending moment diagram. First of all, the shear force diagram. We'll start from point D. How much is the force acting? 3 kilonewton. So the shear force at point D will be equal to 3. Since the load is downward, we'll take this to be positive, plus 3 kilonewton. This is the shear force, 3 kilonewton. Then shear force at point C will be equal to how much? 3 at point C. Consider the right hand side portion. Right hand side. How much load is acting at point C? 3 downward plus 2 downward. That is 3 already. 3 plus 2. This will be equal to 5 kilonewton. So at point C, this shear force will be equal to 5 kilonewton. So since C to D there is no other force, it will be a straight line and positive one since this is plus. Then shear force at point B. At point B, consider the right hand side of the beam. How much force is acting? 3 downward, 2 downward, and 4 downward. 3 downward plus 2 downward plus 4 downward. Total force will be equal to 4, 5, 6, 7, 8, 9. 9 kilonewton at point B. So from C to B, no force acting, it will be a straight line, but at point B, it changes to 9 kilonewton. So see that the shear force is changing at point D, 3. Then no load, constant. Then at point C, again changes to 5. Then B to C, no load, again changes at point B to 9. And at last, shear force at point A will be equal to, at A, total load 3 plus 2 plus 4. This will be equal to 9 kilonewton. 9 kilonewton. So this is all positive. The shear force diagram. Clear? To come to bending moment diagram. At free end, the bending moment is always 0. And at fixed end, the bending moment will be maximum. Now, a relation. If this is a straight line, this will be an inclined line. And how much will be the bending moment at point C? The bending moment at point C will be equal to how much? Consider right hand side portion only. We are considering at point C, how much? Due to 2 kilonewton at point C, the bending moment will be 0 because this is at point C. So there will be only one load, 3 multiplied by this distance. How much is this distance? This will be equal to 3 into 1 meter. This is 3, 6, this is 5, this is 1 meter. So this will be equal to 3 into 1 meter. That is 3 kilonewton meter. Similarly, bending point at point B will be equal to, again consider only right hand side of beam. This will be bending moment due to 4 at point B is 0. We have to consider only these two forces. At point B, the distance of 3 is, this is 3 meter. 4 meter. This total is 6. This is 5, 2, this is 3, this is 1. So the bending moment will be equal to 3 multiplied by 4, 3 multiplied by 4 plus 2 multiplied by distance this much. This will be equal to 2 meter. This is 5 to 3 meter. So this will be equal to 4 3 is 12 plus 3 2 is 6, 18 kilonewton meter. Clear? So last bending moment at C. Again, this is a straight line, this will be inclined line. And bending moment at C, this is a straight line, this will be again a inclined line. So last bending moment at C will be equal to at A will be equal to this force multiplied by this distance, that is 3 into 6 plus this force 2 into this distance, 2 multiplied by 5 plus this force 4 into this distance, 4 multiplied by 2. This is 18 plus 10 plus 8. This will be equal to 36 kilonewton meter. So at point C we have the bending moment of 3 kilonewton meter. At point B we have 18 kilonewton meter. And at point A we have 36 kilonewton meter. Since all the forces are downward, therefore all these bending moment are negative, minus. So this is shear force and this is the bending moment diagram.